The notes for today are atmosphere. We're looking at a couple of sections in all of Chapter 15. So it's 9.3, 16.1, and Chapter 15. I don't know why they spread it around. It's really annoying, actually. Make sure you have a piece of paper and a pen out. You write down the red. Yes, it's long today. I'm sorry. It's like 26 sentences, but it's air. Air is kind of like everything. So make sure you write down the red. Where's my pen? Okay, I found it. Alright, so there's, in 9.3, we talk about types of chemical hazards. The three I want you to know are carcinogens, cancer-causing ones, the chemical mutagens, the ones that cause genetic mutations, and the allergens, the ones that cause us a allergic reaction. They also can cause asthma when it's released into the atmosphere. Please make sure you copy these three down. Please pause right now if you have not. Alright, so looking at 15.1, we're looking at the atmosphere itself. So the composition of the atmosphere is actually mostly nitrogen, oxygen, and a bunch of other crap. So yeah, we're mostly breathing nitrogen, and the oxygen is 21%. The biggest thing is looking at the air pressure, because remember high and low pressures. When we're looking at pressure systems, high pressures are calm days, low pressures are storms. So we'll use this right here, a barometer, to take a look at the different types of pressures. As the pressure changes, this needle will move back and forth. If it's in this area, that means that it's changing. You have the stormy side, which is the low pressure, and then you have the fair or very dry side, which is the high pressure. That's why they can tell where the pressure systems are actually at. If you're not done copying, please pause at this time. Layers of the atmosphere, we've gone over this a little bit, but I want you to know very specifically, so make sure you write these down. 0 to 7 miles, that's air, weather, airplanes. And that's troposphere. Stratosphere is the 7 to 30 miles up. This is the ozone layer, and this is where we have the UV rays. Mesosphere is 30 to 50 miles up. This is where the meteoroids burn up. This is where we see shooting stars. So when you see shooting stars, you're looking at the mesosphere. Thermosphere is where you have the northern lights, and that's the highest level up. This is where our satellites are at. So you can see in this picture off to the right, they give you some ideas. So there's the satellites, you have the shooting stars, here's the airplanes, and then you have a space shuttle going up out. Alright, pause at this time if you're not done. Northern lights, these are actually a result, and I'm going to highlight the important parts so you don't have to copy down the whole thing. So the northern lights are actually the result of collisions between gas particles in the Earth's atmosphere and particles from the sun's atmosphere. These particles enter through the magnetic field. That's why it happens at the North and the South Pole, because the magnetic field is weakest at the North and the South Poles. So when the sun's particles enter through the North or the South Pole, the sun's over here, then you can see the northern lights. That's why we don't see it anywhere else. We've been known to see it in Indiana because this section will weaken and we'll be actually able to see it. Northern lights are actually known as a bad thing. It's the sun particles entering the atmosphere and raining down on us. It's not necessarily a good thing. It's beautiful, but it's not good. Alright, moving on. This is the picture of the solar winds, so you can see here that you have a solar flare occurring and our magnetic field is going to block it. In this case, this was a strong magnetic field. The magnetic field is not permanent, it's constantly shifting, and that's why you can have weak days and strong days. Some days you won't see northern lights at all, some days you'll see northern lights down in Ohio. So you can see here that you have a weak spot, and this is where the solar wind can enter, and we'll actually see the reaction of the sun's particles with our atmosphere. That's what creates the lights. Alright, convection currents. Okay, this is how wind is created. Wind's created when air near the surface heats up, rises. As it rises, it cools, and then sinks back down. That's how we get the different air patterns and the jet streams and everything like that, because you have this constant fluctuation in the atmosphere. I really hope you know this. Seasons. They're caused by the angle of the Earth, and that angle determines the direct or less direct sunlight hitting the Earth. So right now we are in the less direct because it's winter. I really hope you know that. Wind caused by those convection currents, like I said before. I don't know why those two slides are out of order. But this shows you here that when you have the different winds, they are changed based on the equator. So the warm air is going to move away from the equator and toward the poles. So that's why it's different on the northern hemisphere per the southern hemisphere. Ocean currents. They are the combination of unequal heating of water and the unequal salinity. That's the salt content in there, so salt. So if there's unequal salt or unequal heat. Remember, that was kind of the premise behind the day after tomorrow, is that the melting polar ice caps change the salinity of the water, which would change the ocean currents. This is where they kind of got that idea of the day after tomorrow. They just blew it out of proportion. All right, El Nino and El Niña. El Nino is when we have dry periods and really hot. You can see you have the jet stream down here flowing all the way across, and the polar jet stream is just staying up Canada, Alaska, staying away from us. Or not Canada, Alaska, Russia. It's actually warm in Alaska when we have El Nino. When we have El Niña, this is when it's really wet and cold because the polar jet stream has changed and shifted down into the U.S. This is part of the problem that we are having with all of these storms, is that the polar jet stream is pulling the storms from Alaska down into us. A polar vortex, that was when you have this jet stream that you're looking at right now in El Nino. Polar vortex is when the storm pushes against the jet stream down upon us this way. And that's why it's unique, is because it's going against the jet stream. All right, pollution. Yay! Types of air pollution. There's the natural, which is the wind-blown dust and smog from fire, or not smog, soot and smoke from fires and the volcanic. This is how you have natural erosion. And then human sources usually come from burning the fossil fuels. We do this for energy. So when we get into our energy section, this is where a lot of the pollution source comes from. All right, change the slides. There's different types of the air pollutants. You don't have to write any of this down. But there's the primary and the secondary. Again, it's just like the point source and the non-point source. Primary is directly into the atmosphere, and then secondary is formed from the primary when you have the chemical reactions, like the sulfuric acid being produced from the soot. All right, how air pollutants affect your health? Lung irritation, illness, asthma, and cancer. Yay! Smog is the mix of pollutants over the cities. It's a combination of smoke and fog. That's why it's so nasty, is because it's thick. It's thicker smoke. And then you have acid rain. Acid rain comes from the rain going through the atmosphere and catching the atmospheric pollution, so that the rain is now a acid content because of the pH lowered. So, you know, remember water is naturally a 7. When that rain passes through pollution, then the pH will end up dropping to like a 4 or a 5. And we can tell if there's acid rain because we'll see it on the trees, or we'll see it on stone and things like that, because it looks like it's melting away. Controlling air pollution. We can do this with the Clean Air Act. 1963, there's been a lot of revisions since then. It makes us have filters on factories and to clean out what we put in the atmosphere. One of the big things is catalytic converters. We put those on cars now because of the Clean Air Act. Oh, like I said, yeah, catalytic converters. Haha. Lead's been phased out of gasoline, all because of the Clean Air Act. Ozone, the hole in the ozone layer, that was a really big thing where we had to get rid of the CFCs, the chlorofluorocarbons that come from spray cans. Those are no more. This shows the ozone layer. So you have 1955 here, and then 2007. If you look, it did get smaller, but it fluctuates. 2002, there wasn't the big purple spot. 2007, there's a purple spot, but it's smaller than the 1995 spot. So the big thing is we don't know where that ozone layer or ozone hole came from. We don't know if it was originally there even before humans were around. So it's one of those mysteries that, okay, it's there, we just don't want to make it bigger. So we just keep monitoring it. And it's over Alaska. Alaska is part of the issue. They have such intense air pollution that they'll have air pollution advisory days that suggest you do not go out, or if you do go out, you have a mask. If you're sick or you have lung issues, don't go out at all. They're kind of like weather advisories, but they're air pollution advisories because of the ozone layer and the amount of pollution that accumulates up there. All right, that's the end. Make sure you turn these in.
Bye.